In industrial machinery and power systems, protecting equipment from electrical faults is non-negotiable. Two of the most common protection devices are fuses and circuit breakers. While both serve the same fundamental purpose, interrupting current during a fault, their history, operation, cost, maintenance impact, and use cases are very different. In this video, we will break down where fuses and circuit breakers came from, how each works, their advantages and disadvantages, cost and maintenance implications, short-circuit protection capability, and why one is often preferred over the other in industrial machinery. Fuses came first. The first practical fuse was developed in the late 1800s as electrical power systems expanded into factories and railways. They were simple, cheap, and effective at protecting wiring from catastrophic faults. Circuit breakers emerged later, in the early 1900s, as industrial systems grew more complex and downtime became more expensive. Engineers needed protection devices that could be reset rather than replaced. Historically, fuses solved the problem of basic protection, while circuit breakers solved the problem of operational continuity. A fuse is a sacrificial device. Inside is a precisely engineered metal element that melts when current exceeds a defined limit. Once it melts, the circuit is permanently open. A circuit breaker, on the other hand, is electromechanical. It detects overcurrent through thermal elements for overloads and magnetic elements for short circuits. When a fault occurs, internal contacts physically separate. Once the fault is cleared, the breaker can be reset. Short-circuit protection is where industrial fuses excel. High-speed industrial fuses, such as Class J, Class T, or semiconductor fuses, can interrupt extremely high short-circuit currents in a few milliseconds. They limit peak fault current and let-through energy measured as I²T. This makes them ideal for motor drives, servo systems, and semiconductor protection. Circuit breakers also provide short-circuit protection, but they react more slowly, allow higher peak fault currents, and rely on mechanical movement, which introduces delay. In high-fault environments, fuses often provide superior equipment protection. Industrial fuses have several advantages. They provide extremely fast fault clearing, excellent current-limiting behavior, high interrupting ratings, and are simple, robust, and reliable. They also have a lower upfront cost. However, fuses are one-time use, require spare inventory, replacement introduces downtime, and there is a risk of incorrect fuse replacement. Circuit breakers also have advantages. They are resettable after a trip, allow a faster return to operation, can act as a disconnect device, provide clear visual trip indication, and make troubleshooting easier. Their disadvantages include a higher initial cost, mechanical wear over time, slower fault clearing than fuses, and a larger physical footprint in some ratings. From a purchase standpoint, industrial fuses are significantly cheaper per unit, while circuit breakers can cost several times more. However, from a life cycle cost perspective, frequent fuse replacements increase labor costs, and downtime during replacement can outweigh the initial fuse savings. Circuit breakers reduce long-term operational expense in high-availability systems. For maintenance teams, fuse replacement can take 10 to 30 minutes, depending on access, lockout procedures, and verification. It requires tools, spares, and often troubleshooting to confirm the fault is cleared. Circuit breaker reset, by contrast, can take seconds to minutes. Visual trip indicators, speed diagnostics, and no parts replacement is required. This is a major reason breakers dominate in modern machinery. Industrial fuses are typically cylindrical or rectangular, installed in fuse holders or switch fuse disconnects, and passive in appearance with no moving external parts. Circuit breakers have molded housings, toggle handles or rotary operators, and often include trip windows, auxiliary contacts, and communication modules. Breakers are visibly more complex and functionally so. In modern industrial machinery, fuses are preferred for fast, high-energy fault protection, while circuit breakers are preferred for operational convenience and uptime. Many systems combine both. using fuses upstream for fault limitation and circuit breakers downstream for control and maintainability. If this video helped you understand industrial electrical protection better, I encourage you to support the channel by liking this video, leaving a comment with your questions or experiences, sharing it with your colleagues, and subscribing to receive more detailed technical insights every week. Your engagement helps us create more content that keeps your industrial systems safe and efficient.